This question is titled, How do I run things? And I want to talk about how I launch processes in the foreground and background, how I group processes or launch them in subshells, what jobs are and what job control is, and how this ties into how a simple shell script can do something that a Python script or another tool might really struggle to do simply, tersely, effectively, readably, or maintainably. But let's start off with this. I have a simple hello world shell function here, and all it does is it prints out hello world and a value. And I could put this in parentheses. I could put this in curly braces. I could put this with like an ampersand after one of these. And what is the difference? You can see some very interesting things happen here. This 5 does not seem to be printed anywhere. That's kind of odd. And otherwise, and I guess if I do like a wait here, you might see that 5 eventually get printed, but it seems to be printed out of order. And you can't really tell what's the difference in that parentheses and those curly braces. And you might think, maybe this has to do with subshells, because I've seen subshells before. So let's see what the process ID is for just something at the top level, something within the parentheses, and something with the curly braces. Well, they're all process ID 1. That's not so useful. And I might dig around a little bit, and I might say, you know what? Something's happening here. So what I'll do is I'll launch a process from each one of these things, and I'll ask what the parent process ID is. And then finally, I see what the distinction is. Parentheses mean run the included commands in a sub-process, in a sub-shell. The curly braces in shell just mean group these commands together. That's all it means. And that ampersand says run something in the background. When you are writing a shell script, largely your main task is either to construct a command line command to be run or to execute a command line command. And when you want to execute a command line command, you could execute it in a variety of ways. You could execute it in its own isolated environment, i.e. a subshell. You could execute it in a blocking fashion so that it has to complete before the next thing can run, or you could execute it in a non-blocking fashion so that it runs in the background and maybe you need to wait for it to stop, or maybe just let it run to a completion. And in some cases, you might need to group things together, like in a for loop or in a function call. And so you may have seen the for loop syntax that most people use at shell, for x in sequence 1 to 10, do, echo x, done, something like this. But you might not know that in Z shell, you actually can do this. Almost looks like, let's do the semicolon here, just to group these. Almost looks like C++ or C, or kind of like a marriage between those and Python. But this just means group these commands together and don't run them in subshell. That's all this curly braces mean. I want to talk about what the ampersand does. The ampersand says, I want to run multiple commands and I want to run them simultaneously. And if you remember, when we're dealing with a pipeline implicitly starts every process in that pipeline and runs it simultaneously. Well, this says I want to run one command, not connecting its data to anywhere, just reading from whatever the same standard is, writing to the same standard out, and I just want to run that in the background. And here, I'm just going to wait for this to be completed, and you can see there you go. If I don't wait, well, my auto runner runs this, terminates, and because I'm running this with that BRAP, kill all the child processes when you terminate, it's going to kill this child process. Let me show you behind the scenes what happens. And I'll put my wait here too, just to make sure that stays alive. When I do this, if I look at the PS tree, I have my shell script, and I have as a child process of that shell script this thing running in the background. And you can see when it's done running, it prints this to the screen. This number is the job number, and it tells me, oh, sleep 10 is done running 10 seconds later. Or at least this is my job output. So here, when it's done, it should print, in an interactive mode, it'll print something. In a non-interactive mode, it won't print anything. I can use this effectively in a way that is actually very clumsy for me to do in most scripting languages. What I'm going to do here is I'm going to create a FIFO. I'm going to create a named location on disk that I can write single lines to, what's called a named pipe, a location where I can write single lines of data and read single lines of data that can be used to bridge multiple processes together. And so what I'm going to do is I'm going to play a very simplistic game of FizzBuzz where I'm going to go through the numbers from 0 to 100, grab every number that has a 3 in it and write them to this FIFO. I'm going to do the same thing with this 5, and I'm going to run them in the background at the same time. Now I'm going to sleep for 1/10 of a second just so that there's a little bit of time to sleep between them. And I'm going to have another piece here that just watches what's in that FIFO and pulls out the lines from that FIFO and prints them to the screen. And you can see a very chaotic game of FizzBuzz. Both players are playing simultaneously, jamming files into that, but they're running in the background. They're truly running simultaneously. One of the big challenges that we have with Python scripts is we want to parallelize something. We want to run two things truly simultaneously. And we know that with threading, well, the global interpreter lock prevents us from doing two computations simultaneously. We know with async I/O, it's fundamentally single-threaded, and so we're stuck with multiprocessing. And that multiprocessing approach can sometimes be a little bit clumsy. In Shell, it is as trivial as adding a single ampersand to just launch something in the background and let it go, and waiting for it to finish writing. And if we need to write to a common location, we could create a FIFO or an actual file, and we could write to it as we go. Now, obviously, these two processes could clobber each other, so we have to be a little bit careful of that. But you can think, Shell is very good at launching things, connecting them to each other, and managing them to run. And this is one of the sweet spots of Shell. The execution of underlying processes tends to be terse, parsimonious, and very easy to control from Shell. Here, if you think about it, a large amount of our Shell vocabulary is really about connecting things to other things. It's really about controlling how something launches. Here you can see I have a file called data. That's all the numbers from 1 to 10,000. And I can connect the output of these commands to the input of these commands using this sub-process substitution. And this is really where Shell excels. Because to do this in Python, I'd have to do check output, and I'd have to decode it, and I'd have to make sure it's good. And yeah, at Shell, it's a little bit clumsy. I have to use this cut. But for the most part, this is going to be twice as long in Python. If it's anything more complex than that, it's going to be even longer. And here, these are one-shot programs. I run the program, grab its output, and I'm done. Okay, subprocess.run, subprocess.checkCall, subprocess.checkOutput. Sure, they get that pretty easy. But if I wanted this to linger in the background and I wanted to communicate with this as I go, I'd have to use subprocess.popen, which is very complicated. And every time I look at the API for subprocess.popen, my head spins. Whereas in Shell, I could just start a coprocess. A coprocess in Bash and Z Shell is just another process that runs in the background, and you can read and write to it as you go. So here's a very simple coprocess. It just does sequence 1 to 100, the first 100 numbers, looks for any number that has a 3 in it. And here's the main Shell process that can read from that or write from that, just using this special file descriptor P. And I can do some fancy things when I combine these really simple tools. Here I have a Shell script that I'm going to run in the background that does a sleep 5, blocks until that's done, and then runs to the sleep 5. What I'll do is I'll run this whole entity in the background. I'll sleep for 1/10 of a second just to get that thing started, and I'll look at my process tree. And I should see just one sleep. And if I waited for, say, 5-ish seconds here, I should see that other sleep get started. Maybe we'll do a sleep 3 and a sleep 5 here, and we'll sleep for 3 seconds in between. So we should see, there we go, and then 3 seconds later, it should pop up, and it should be on the sleep 5, and there you can see, and it's a different process ID. Well, if I want to run these in parallel, I just put an ampersand at the end, and they just launch in the background. And I could just wait for all of my child processes to finish running. And when I look at my PS tree, I can see they're running in parallel. And it's almost trivial for me to do this. That's even simpler than anything you could do in Python with the multiprocessing module. If I wanted to ensure that they were terminated, I could even very easily terminate them by setting a trap at this level. I could say trap any interrupt, any terminate, or any exit signals. And when that happens, turn off the trapping for sigterm so this doesn't recursively keep trapping itself. And then I can ask it to kill with a interrupt signal any process in the same process group. Because what happens when you launch these background processes, these background jobs, is they're within the same process group. So you can kill the entire group at once. And so here, what will happen is these things are running in the background. And if I sleep for 1 second, and then I kill this thing as a whole, it'll kill all of them. And to show you that this works, I'll actually run these as Python processes instead. You'll see both of those Python processes. Then I'll kill with an interrupt signal this thing, and it kills all the child processes. So if I had some complex runner that was running like 5 things, that launches 5 things that run simultaneously, little monitors or dashboards for me, I could easily, trivially in shell say, if you control C at the top level, just cascade down and kill everything all at once. That's actually pretty tricky to do in pure Python, very easy to do in shell. I could even do something more sophisticated. Here's an example where you can see this Python script can even handle a sig term. So you can see that this thing launches these processes and then, let's actually wait here, and then goes ahead and terminates them. You can see them being launched and then being terminated. And again, you couldn't beat the ease of launching, executing, managing these processes. Now, there are limitations because if you need some very complex control flow between these, well, the shell doesn't quite give that to you. If you have a script which is executing, not just planning something, but executing something, and it needs to launch things in the background, or launch one long-running thing in the background and communicate with it, or if it's launching some things in the background and just needs to communicate over a pipe, just, sometimes this thing passes to this and this thing passes to this, and you can express most of these very simply in terms of, create these FIFOs, and one of you writes here and one of you reads from here. Shell does this at a level of simplicity that you couldn't get in Python, and a level of terseness, and a level of just 6 lines of code and you're off to the races. And this is one of, I think, the key places where I find I really do prefer going to shell over going to any kind of scripting language because, it's purpose-built for human-level automation, augmenting what I would do as a human being, running commands, but adding a little bit of automation so it eliminates the tedium while we're still retaining the flexibility that the human being can bring to this process.